So in the last lecture, we started with age linking, and we also discussed why we need to apply this age linking algorithms. So in last lecture, we have seen local processing, and in that we saw that the two conditions should be satisfied. Then only we can say that the next pixel is connected to the current pixel. So we had considered there the strength or the magnitude of the gradient and the direction of the gradient. Okay, so it was a local processing. So now we'll continue the age linking using global processing. Okay, so we'll see global processing, age linking using global processing using Hough transform. So very widely used and very important to learn. So a Hough transform is used for pixel linking and curve detection. So points are linked by determining first if they lie on a curve or a specified shape. The global relationship between pixels is considered. Given a set of discrete pixels, the Hough transform checks if these pixels or these points lie on a straight line, and if yes, it draws a line joining all these points. Okay, so a Hough transform is best explained by an example. So we are going to consider one example. This is your y-axis, okay, and this is the x-axis. So we'll take one point, okay, x1, y1. A line passing through this point, okay, if the line is passing through this point, we can use the equation of straight line and we can represent that line, right? So I can write this as y1 equal to ax1 plus b. So this is which form? Y is equal to mx plus c. So you know this is slope intercept form. Okay, a is slope and b is intercept. Okay, so using this equation and varying the values of a and b, we can plot various lines passing through the point x1, y1. So I can plot like this, I can plot the line like this. So different slopes and different values of a and b. So a1, b1, then you have a2, b2, then you can have a3, b3, a4, b4, and so on. Okay. So instead of writing the line equation like this, if we want to write in the form of b and a, I can write b equal to minus ax1 plus y1. Okay, and can we consider that AB plane? Okay, what can we consider instead of XY plane? We can consider the AB plane. Okay, instead of X and Y, now we will consider B AB plane. So here now the variables are, in this case X and Y were the variables. In this plane, A and B are the variable. Okay, so we get here now. Here we'll get one single line for a point x1, y1. Okay, so I may get a line for this particular point x1, y1 in xy plane. Okay, I will get one line. Okay, so I can write this line as b is equal to minus ax1 plus y1. Okay, this entire line in the AB plane is due to a single point here in XY plane. Okay, so different for and different values of A. So what I'm saying here is the point in XY, the point in XY plane gives us a line in AB plane. This is very important. Okay, the point in XY plane gives us a line in AB plane. and the line in xy gives us point in AB plane. Okay, so now if we consider another point x2 y2 in the xy plane, the slope intercept equation will be what? Y2 equal to ax2 plus b, right? Writing this equation in terms of AB plane, what will get? B equal to minus ax2 plus y2. Okay, so this is another line in the AB plane. Okay, so I can represent this. I can represent this like this. So this is my y, this is x, and suppose this is a point x1, y1, and this is another point x2, y2. Okay, so I will, if I convert this, okay, instead of xy, if I want to represent these points in AB plane, I will get one line for one point corresponding to one point. So I'll get two lines here. Okay, one for x1, y1 and another for x2, y2. So this will be b equal to minus ax1 plus y1, and this will be b equal to minus ax2 y2. Okay, so this is your b dash, this is your a dash. So these two lines will intersect each other somewhere in the AB plane, okay, only if they are a part of a straight line in XY plane, okay. If x1 y1 and x2 y2 are collinear in XY, then and then only these two lines in AB will intersect in one common point. Okay, the point of intersection in the AB plane is noted as A dash B dash. Okay, so using this A dash B dash in the standard slope intercept form, that is y equal to A dash x plus B dash, we get a line. Okay, we'll get a line that passes through x1 y1 and x2 y2 in the xy plane. Okay, so in fact, if we have n points, okay, that lie on a straight line, we get n lines, each line will representing a point, right? So we'll get n lines in the AB plane, and these lines would intersect at a single point A dash B dash in the AB plane. Okay, so for example, if this is your y and this is your x, what I'm saying is if you have so many pixels in xy, okay, so this if you convert into AB plane, AB plane here, so how many points are there? 1, 2, 3, 4, 5, 6, 7. So we will get 7 lines. 1, 2, 3, 4, 5, 6, and 7. Sorry, this is and 7. Right? Okay, 7. So what is the meaning of this? There are 7 points in xy plane. Okay, we will get for each point here, we are getting a line here. So there are 7 points. So there will be 7 lines in AB plane. Okay. Now what I said, if what we said here, that if all the 7 points are collinear, then all the 7 lines in AB will intersect here in one common point. Okay, and that common point will give us B dash A dash, and with the help of this B dash A dash we can get the straight line equation, and we can plot a line which is going to pass through these 7 points. So this 4, 5, 6, 7. So we'll get a line, this line, okay, which we can plot through these 7 points. Okay, so this will be y equal to a dash x plus b dash. So the AB plane is called the parameter space. Okay, so in the next lecture we will solve a problem based on Hough transform.